One of the things that attracted me to this card as compared to the card that Grant used in his MultiComp is that it's completely compatible. It's all part of the same Cypress or Altera Cyclone family. One is the Cyclone 2 and one's the Cyclone 4. And here's a comparison of the two parts. The one he used was an EP2 C5, and it's readily available for about 12 bucks on eBay from the usual sources. And it has 120K bits of RAM. The chip used on this card is the EP4, a newer Cyclone 4. It can work with the newer Quartus tools, which is nice. And it has 270,000 bits of RAM, which is 125% more. Now, the other one was a good choice, but you couldn't get more SRAM internally on the card than 4K. And we've already seen that we can pretty easily get 16K with this card. And although 4K probably would work for most things, I thought I'd try to trade up on it. In bytes, that is, here's the numbers that is in bytes. The other thing that you get out of this card is the larger amount of logic, and it's not a ton more, surprisingly. It's only 36% more, but Grant's design pushed the limits of the EP2, and there wasn't a lot of space left in there to do extra functional things, and that reflects into the LABs as well. A little bit more I/O really didn't matter. Claims a slower clock frequency, which I found to be kind of interesting, but everything we're doing is really at 200 megahertz, much less than that. I think the fastest we anticipate doing is the connection out to the SD-RAM, which would be at 100. But everything we're largely doing is running off 50 megahertz clock into the card. So this is the comparison, and this is why I think this card is a good choice. Plus, really having the VGA, Ps2, and USB to serial built on and all on one edge of the card, as I've said before, I think is a killer combination. If we can get the RAM to work, then we should be able to get the full possibilities out of this card. The only limitation being the I/O, and for hooking up things like an external SD card, that could be a challenge. I created a small test bench to evaluate how many logic elements each of the things use. So I flipped that previous table around here, and we'll take a look at each one of these elements and try to come to some determination. I've got 2 pages of this. The first page is CPU and basic required elements, and not actually all required, but these are part of the processing itself. The other page is for peripheral stuff. So looking across here, the 6502 is pretty efficient. It's only using 13%, or 839 out of those 6,272 logic elements for a grand total of 139 registers. None of these processors use any of the RAM at all. They're all completely done in logic. 6800, which I haven't shown here, just grabbed the core off. I think Grant put it up, but it doesn't have support in terms of operating software. It looks like it's fairly efficient as well. It uses 1058. Now, I've always liked the 6800 family better than the 6502 family. I think it's a little easier to program in assembly. The Z80 looks like it's the hog of the bunch, and it's using twice as much, and perhaps it's better, perhaps it's worse. I think there's definite fans out there for the Z80. And somewhere in the middle between the two, between the 6800 and the Z80, is the 6809 at 1700 logic elements. Again, fairly amazing that all of these CPUs are 1 to 2,000 logic elements. Boy, they were cool in the day, and $100 to buy them when they came out, maybe more, probably 500 bucks for some of them when they came out. One of the other pieces that I've gathered is Neil Crook's memory mapper. He's using it with the 6809, and he's doing some pretty cool stuff up there. If you haven't got a chance to check it out, it should just work on this card without many modifications. I haven't tried it yet, but it is the basis of the 6809 CPU. He took the one that Grant had and fixed a lot of the things that were deficient in it and made the timing better for it. But his memory mapper lets you hook up external RAM if you have it and map it into the address space by swapping it in to that 6809 address space. Neat, not a huge cost, about 4% of the LEs on the card to do that. Basic and ROM predictably uses 8K for the 8K basic and ROM, and it's the same across all 4 of the configurations. Now when it comes to Segmon, Grant did something pretty cool, which I think I'm going to steal. Neat function. Instead of having that loaded into RAM, he puts it in logic, so that 2K of RAM that would be gone is saved. Now he had to do that because he only had 4K left with what he did, but that was a neat hack and didn't seem to be horrible, except if you look at the 26%, it's about a quarter of the logic here inside of this part, so it's fairly significant. And Segmon, the only real thing advantage-wise it gives you is machine language editing and loading and that sort of thing. If we had a simple loader in BASIC, we could probably load through BASIC. Now, the other thing it does give you is some debug capabilities. You can set breakpoints and things like that. So that may be a way to go to play around with it. Maybe develop programs, and you could always swap it out and have more space if you needed it. But it would be hard to do development with that there. I mean, it's twice as much space as the CPU is, quite a bit. Grant did the same thing with the character ROM for the display, that 8x8 font that he uses, and that uses 18% of the ROM space. So again, another trade-off there. He was trying to preserve RAM, and this is where he ended up going, and it makes a lot of sense. I'm going to use that same technique for the music synthesis section I'm going to do here, coming up hopefully pretty soon, as soon as I get around to it. I looked around on the internet to find a better font when I was trying to make the video screens, and found a better one. It's a 8x12 font, but it uses 16K of K-bits of memory, so that's another choice that could be made. Of course, the 16K of SRAM surprisingly uses a little bit of logic, but not a lot, but it uses up 47%, which is nearly half of all the logic elements on the card, and that makes some sense. In fact, there's only 30K in logic elements, so it's a little bit of a surprise it's not bigger. I'm probably doing some math here wrong. We have two different video choices here, and one of them is the ANSI video, which is basically emulating a VT100 terminal. It has a serial interface into it. It's a very neat interface. It really does work just like a 6850 or like a VT100 would have. You can set colors on the screen and do things like that. But it comes at a pretty significant cost. It's 24% of the card's resources, and it uses a fair amount of RAM too. It uses 15% of the RAM. Some of it's for display RAM, some of it's for other things, like there's perhaps a Uart buffer maybe and some other things in there. But that's a significant, very cool function, but about a quarter of the logic elements on the card. The other video choice is the UK101 display, and that's a 2K of memory, 2K of SRAM. I think I got, it's missing here because it's down here. This is just the logic part of it, and if you look in the previous video, I put up a much simplified version of that, and it's basically just the horizontal and vertical counter, so that explains the small gate count, the small register count here. It does use RAM. It's that external 2K display RAM, but it's not hooked up to it internally, so I had to do it on my test bench a little bit different here. That 2K RAM does use 2K of memory and no logic. Ps2 Keyboard, there's sort of two twists of it. One is the keyboard itself that Grant found out on the internet, and I can't remember the guy's name who did it. I'm sorry, I'll try to remember to give credit in the notes if I can find it. Anyway, no, it's in the comments. You can find it there. That's pretty efficient. It only uses 44 logic elements, much less than 1%, and it's a pretty clean little design. Doesn't use any RAM as well. The UK101 keyboard, though, Grant does emulation of the UK101 row and column matrix keyboard. So he takes in what comes out of the PS2 keyboard module and flips it into rows and columns, and then goes and scans it. It's good because it makes it compatible with the Ohio Scientific, and even more importantly perhaps than having characters come in is that when you hit keys in some games, they have to do certain things, and that there's many games that went out and poked and peeked the row and columns of the keyboard, and that wouldn't work if Grant hadn't put that function directly down in there. Buffered Uart, let me go grab that number. buffered Uart uses 189 logic elements, so it's only about 3% of the total, but it does use RAM, and again, this is a little deceptive in the way that Quartus presents this, because this memory is all locked up. It's a full block. It's for buffering for in and out. Very nice design, altered by Neil Crook to make it more synchronous, and he definitely cleaned it up. He changed the clock, though. If you try to use Grant's and try to use Neil's, they're not exactly compatible. Instead of giving it a 50-50 duty cycle clock, you have to give it a 1 in 16 clock, or excuse me, a clock that's 150 megahertz pulse wide that matches the 16x baud rate. So it's a little bit different. It takes a little bit of external circuitry to do it. I think I'm using it all the way through everywhere what I have. So be a little bit cautious in terms of being able to grab pieces out of Grant. You can't just grab his baud rate generator and use Neil's buffered Uart. Probably want to grab both mine or Neil's, either one will work. And the baud rate counter I haven't included, but it's not a significantly large space. So I've made a bunch of other elements, and most of these are ones that I've created and some aren't, but just to see and test and determine how big things are. 28-bit counter uses 28 registers, 28 logic elements as you'd expect. Loadable counter, which is, I forget how many bits it is. I think it's, well, it looks like it's 20 bits wide. Uses 48 logic elements, and that's going to come in handy for the sound work I'm going to be doing here pretty soon. The UK101 display RAM, I think I had that on the previous screen, but it looks like I've got it here twice. I could probably get rid of it off here, so we don't really need that here. 7-segment loadable display uses 39 logic elements and 20 registers. It uses the counter loadable below it, I believe. Not sure why it's set up to use. Did I delete something wrong, or I must have copy-pasted something here. I question that number. I don't think it really uses any RAM. If it does, I'll go double-check it. I don't think it does, though. The 7-segment elapsed time counter that we did earlier used 101 logic elements or 64 registers. Nice little design. I think I'll keep that elapsed time counter inside the computer somewhere and have a way to read it that doesn't have trouble with the fact that it's a much bigger counter than what the CPU can read. The CPU can only read a byte at a time, and if it started to read bytes across a multiple byte counter, one of the bytes could change and the time would be inaccurate. So I'll probably have to make a snapshot latch for that and then read that snapshot latch. That probably could be done pretty easily by, if you read the first location of the 4, then do a snapshot while you're reading it, and then just read the next 3, and that'll probably do the job. One of the things that Neil took that Grant had done was Neil took Grant's SD card reader, and I believe that he made it work with SDHC. I don't think Grant's did. Not totally positive. I know I'm running it on my other MultiComp builds with a regular SD card. The downside of what was in there was that it could only be cards that were 1 or 2 gig. It couldn't support SDHC, so it was a little bit limiting. I had a hard time finding old SD cards. In fact, I bought a couple of cards from eBay that were labeled as 1 gig, and when I put it in my computer, of course, they were 2 or 4, or excuse me, 4 or 8. I think 1 or 2 both were. I think it has to do with 32-bit address space. So it's a little bit more complicated to find them. Found them in actually my friend who works for a respiratory therapist who gets CPAP machines in, and the CPAP machines have loggers in them, and that Philips Respironics CPAP machine apparently has 1 and 2 gig SD cards. So he gave me a collection of those from his nurse fiance, and that was a nice that was a nice way to get a bunch of cards to do CPM on the Z80, and that can be done, except for here again we're I/O limited. Simple 8-bit latch you would expect to be 8 bits, and it is for logic elements and registers. And one of the things that I really wanted to know was how big that Uart was, and it says screen swap here, but it's really just the dual Uart part. As I pointed out, I have that back over here. It's 189. I must have done that twice. Yeah, it's 189 out of 6272. I guess I really don't need it on this screen if it's on the other one, because it really is going to be part of anything that you probably build. Otherwise, you really can't download programs reasonably to it. Left off the switches, function keys, buzzer, sound is going to be different because it's going to grow. Right now it's not very big. And there could be an option here for CPU speed, but I haven't included that chain. It's only a few bits worth of counting, but I'm thinking a function key, because that seems to work pretty well, could be used as a clock speed selector like an old school turbo button. So right now we have 4 different systems configured and working. UK101, which I put into a project called UK101 All Feature Set, which includes all the features that we have developed so far. Then there's an OSI 6502 VGA version, a 6809 version, and a Z80 version. And here's a features list of all of them. Only the UK101 has the Segmon machine code monitor in it, and none of the others do. I think it would be nice for playing around with machine code. I wish that it was in the VGA 6502 version. They're all using an 8K basic and ROM, and that 7-segment display I've got working on in various forms. Have it working as a 7-segment display in the UK101 All Feature Set because I think that's superior to what I'm doing on the other cards. On the other applications, I've got it set up to use to reflect the transmit and receive, the state of the F1 key, which we'll describe down lower, and a latch bit that you can control from software in the CPU with peaks or with pokes. The SRAM, there's a Crazy Ape mod out there that I haven't got to talk about much yet, but he's done some more Vhdl guru foo and shuffled around the block RAMs so that all 9 bits can be used. Quite a neat hack that he did for it, and it took the 19K that we had up to 21K in that instance. So it was a nice couple of K. It looked like a lot of work, and again, some smart guy effort there. The other 3 only have the 16K. I haven't put that 9th bit fix into all the other ones. I've only run that one at, I think he said he ran that at 10 megahertz. I've only run it at 1 megahertz myself. We have a couple of different video formats. One is the SVGA controller, which I laid out in the last video, which uses the memory mapped 2K shared dual port memory and a pretty simple counter. The second configuration is common to the other 3 hardwares, and that's to have VGA and not memory mapped, but have an interface that looks like a buffered Uart, sort of an emulation. Ps2 Keyboard, yeah, they all have that, except the one for the Ohio Scientific to fit in with the code that is already in ROM on the Ohio Scientific. Grant had to do some magic to turn key presses into row and column as if it was a scanned matrix array. They've all got 1 Uart running on them right now. They could easily run 2. There's no reason not to be able to do that. The UK101 card right now is set up for 300 baud because that's just easier for uploading and downloading. The other 3 are all set up to be switchable by pressing one of the function keys between 300 baud for uploading to the card or downloading the card, depending on your perspective, or 115 2K baud if you want to run full out. That's all working as well. I don't have the screen swap set up with the UK101. The reason being it's different because of the memory mapping. It can't really be done. In the case of the other 3, when you press the F1 key, it swaps between the primary display being the Uart or the primary display being the display. And that's done because Grant's created this Uart interface for the VGA that if you send out characters to it, it looks just like it's a 6850 Uart. So the swap is really just changing the memory map. There's really no equivalent possible on the UK101 because it doesn't use that Uart interface. They all have the read switches going to read the buttons, 4 buttons on the card. I think most of them I've got set up as the left button is a reset for the card, and the other buttons are all readable. And if you read them, you read 7 if you're not touching a button, and if you touch a button, you get the bit set low for the button you press. Function keys will not work in the UK101 because of the way the row column mapping is done. But the function keys are working in the other configurations, and right now F2 does the baud rate, and as I said, F1 swaps the ports in all 3 of those configurations. They all have a latch, but the latch does something a little bit different in all of them. In the 6502 case, the D0 makes the LED go just like it does up here for the latch, except, and D4 through D7 set out a tone, and it's at the address FF D4 65492 in decimal, and it can be poked from basic to create tones. I'm going to do another video series on that, and I plan to make music better than just 4 octave apart tones. The buzzer works on the UK101 and the buzzer works on the 6502, but I haven't backported it to the 6809. It does work on the Z80 though. The sound is, as I said, 4 notes and 1 octave. I think there's something inconsistent. This one must have that same logic inside of it. I didn't backport the sound to the 6809. It's just a lot of work to put stuff back into other configurations I've built, but if you want it in a 6809, you could go grab it out of one of the other 2 configurations. The CPU speed has been tested at 1 megahertz in a UK101. It's hard to go faster in a UK101 because of the row column keyboard. If you run at a higher speed, there's nothing about the processor or the RAM or anything else that doesn't let you do that, but there would have to be some determination inside of the ROM inside of it how to slow down the keyboard polling rate. And I think I've seen that in the Segmon documentation, so there's probably a way to get there. The other 3 all run at 25 megahertz with no issues. Now I've put the total number of logic elements down here. It looks like the UK101 uses the most logic elements, and we'll take a look at why. The Z80 isn't far behind, and the 6809 is also not far behind, and again we'll look at why. But the 6502 with no Segmon in it is the most efficient for LE's total, and it has it's kind of amazing how they did what they did back in the day with the little bit of logic they had, and we'll take a look at each element and try to understand why they use what they use. The total memory bits are completely consumed in the UK101. The 6502 and the others, they're all using 86K. Now that's really not true because of the 9-bit, 8-bit memory. If we put the hack that Crazy Ape did back here down into those, we could get a little bit more, but really at 86% they're full as far as the width-wise goes. It just doesn't show what happens with that extra bit because it's unused. So basically we're at 16K of SRAM. We're pretty full on memory on these configurations. And I've thrown down the PLL numbers. The only one I really put the PLL into was the UK101 to power the various clock things. I'm taking note here also that the scroll, for some reason, when you reach the bottom of the screen, is broken, and I don't quite know what I did there. Let's take a look at what it takes to figure out how big a particular element is. There's probably better ways to do this, but I've created a test bed that has basically nothing in it. All of the parts have been moved off to another folder. So when I come in here, I get rid of whatever's in here, and so I have nothing. And then I'll go over and grab whatever thing I want to evaluate for size. And it has to be have no dependencies, and if it had dependencies, you'd have to bring them in. But I put all of those elements inside the GitHub location under the Vhdl template folder. And if we wanted to look at how big a particular counter was or something like that, you would just go in here and grab it. But let's do it for the character ROM that's in the UK101. If we do that and select it, then we go over up to start compile, and it'll compile that. I'll probably trim the video here so it doesn't take a while. I've just noticed not long ago that the bottom corner here has a 1%, 2%, tells you what percentage you're at, and then an elapsed time counter down there so you can tell how long it took to compile something. Everything seems to take some time. I'll let the video camera run, but I'll probably trim this out. Well, it's complaining, and it's complaining here because I forgot to change the name of the top level entity. So that's pretty simple. You just go up and set that as a top level entity and then tell it to go to compile again. spinning on time. It usually gets pretty quickly to the point where it knows whether something is wrong from a project perspective or a syntax perspective, and then it has to crank through the fitting it into the part and the other things. That just quickly popped from 2% to 20%, so I think we're well on our way. 23%, we're at 40 seconds. I'll let it run and probably trim the video, or at least tell you where to go in the video to skip the compilation, unless you like to watch things compile. There we go, now we're cooking with gas, 29.32%. 43%. I'm running this on kind of an underpowered machine. It's an old Optiplex 780. I got it for probably 150 bucks. A faster CPU would definitely help, I would think, here. And it looks like it's done. So from that you can grab the number of logic elements that it used. This particular character ROM is coded so that it comes out of logic and not out of RAM. You can see there's no RAM use, but there is logic use. Grant's taken a 2K character ROM and synthesized it as logic, so it's using up 1100 logic elements, which is 18% of the total logic elements. Well, for MultiComp we have plenty of logic elements left over, so that's a good trade-off to not take up the 2K of RAM. And he had to run in a smaller EP2 part, which had less memory, so definitely this was a good optimization. In fact, we could probably use that optimization ourselves to tweak some of the other elements that are ROMs and put them into logic. The 8K basic in ROM would be a possible target, but I could see if this is what, roughly 1100 bytes out of 2000, so it did a little bit of compression. I could see eating up 4K worth of space for that ROM, so that might not be a good solution, but it'd be something worth trying. I'm going to illustrate an example here of what not to do when naming files for Vhdl. I've created an element test bed, and in the element test bed I basically got rid of everything out of it except for the 6502 CPU, but it's in the same folder as the other elements that are being tested. But I wanted to use something that was an existing thing so that if I wanted to play with I/O pins I could. So I started from the 6502 VGA function and eliminated all the files. Well, a common mistake, I think, and mistake that I definitely made here, is that when I created my elements, I created them with a name for the file that did not match the name for the element inside of it. And when you go to create or to compile that element, if you're trying to just test it by itself, then you end up with the inability to set. You can set the top level entity, but what it does is not take the entity out of the file, but it takes the entity out of the file name here. So when you go to compile, you're going to get an error pretty quickly. It's going to come up and say that it can't find that file. There's only a few that I've created with the same or different name. Most of them I created the same, but the how I get around it was to temporarily go in here and change the entity name and then go back and undo it after I was evaluating how big it is. Looks like it's still compiling. Would have thought it had been a little bit quicker than that. This is only a counter, but let's see what it comes up with. Yeah, see there it's saying that it's undefined, and when you go into the file you can see that that entity name and the entity name inside of the file don't match. So two ways to do it. One is you can go in and change the file name in here, which would be good, but any place that's using it in the project would have an issue with it. At least it would be called out correctly inside of the Vhdl file itself that's calling it, and you would just have to point to the new file name. The other way is to take this file name without the VHD extension and put it in here, and that's what I chose to do to evaluate the size of the functions. I wish I'd made them all with top level entity as the file name. It would have made life a lot easier to go through and evaluate this, because I wouldn't have had any conflicts. If you've previously compiled something, you can see how much resources it uses by going into Tools and, Processing, then Compilation Report, and it'll pull up the results from your previous compile. If you change files, of course, that number would be different, but this is nice. You don't have to recompile the whole thing. In this case, we can see that the last time I built the 6502 project for this processor, if an element has more than one dependency, then you need to include them all here. So the UK101 keyboard has a dependency or a lower level entity that calls out the Ps2 interface. So I've selected both of those. And you can see that down here inside of the file for the UK101 keyboard, it is calling out the component below it of the Ps2 interface. So if you don't do that, then Quartus will complain and tell you that you need to include other things or it can't find stuff. But this is a good way to check things and the things that are below that thing for how big they are. Oh, and don't forget to set your top level entity, otherwise you'll get a complaint about something else that you compiled earlier. And that's pretty simple. That's just right-clicking on the top level entity and setting as top level entity. Another way to fix the name, if you change inside of the file to make it compile an element all by itself. For instance, this one, before I changed it, it was called lapse time hex counter, and then after I changed it, it was called the same thing as the file name, loadable 7-segment 4-digit LED. Another way to get there is to go in and delete the one that you just created. I can see this one has today's date on it, and then go and rename the previous one by getting rid of the .vak, and that'll restore it back to what it was. And of course, Notepad says, hey, I don't know what you just did, but I'm not happy about it. But you can see here the result that the file loadable 7-segment 4-digit LED has now been changed back to the prior contents, which had the entity named as elapsed time hex counter. I guess the best way to do it is just make your top level entity and your file name the same, but I found different practices that other people have. The advantage of renaming the file is that you can have multiple entities with the same entity name and change between them just by changing the file you hook into. But it makes it much more painful here when you go to evaluate that piece all by itself and see how big it is. And there might be a way to set the entity to something else other than right-clicking and setting it, but this is the way that I've found that works for me. Here's another tip. If you're trying to make your top-level entity the same name as the entity in the file name and the entity match, then you can't have dashes in the entity name. It gets confused in Vhdl. It needs to be something like an underscore or mixed case letters or something like that. So this one, although it includes and works perfectly fine, it only works perfectly fine when it's not a standalone piece, and it's the top piece here, so it's got a little bit of an issue with that. So I've got to go ahead and rename that one back in the folder that it's in. Hopefully this summary helps you determine what you want to do, because there are a lot of choices here with this. Definitely they've each got their strengths and advantages. I think if I was just doing assembly language programming, I would probably pick the 6809. The UK101 certainly has the historical feel to me. And again, it would support assembly language through the Segmon, but you'd have to learn Segmon. I think there's a nice trade-off there. The 6502 version has got a lot of advantages to it too, being able to run at 25 megahertz. Certainly going out the serial port at 115.2 or 300 is nice for all of these. It makes development pretty easy. You can easily, slowly upload to the card at 300 baud and then run it 115 too after you're up there. So there's something to be said about that too. It's almost a pretty nice smorgasbord with the UK 101 being a little bit different here. It's not completely interchangeable. Some of the pieces easily could, some not so much, because for the video you're really stuck with it. But of all the videos, if I'm doing a home rolled system, this is definitely, the UK 101 is definitely the most efficient. You just write a byte to memory and a character appears on the screen. It can't get much simpler than that. I'd like to benchmark the ANSI VGA setup that Grant did. I'm not really sure how fast it would run. Does it keep up with the Uart, or if you do a screen clear, does it disappear for a while? There's a lot of functionality in there. I think a neat way to benchmark that might be to make a buffered Uart and have the CPU read from the buffered Uart, send it directly to the screen, and then have another loop that the CPU looks and sees if there's anything from the Ps2 keyboard, and if there is, it sends it out the serial port. It would make a nice little VT100 terminal. I don't know how much the processor in the middle will get in the way, but that's this Excel spreadsheet for the tested list, called tested_list and .xls, will be loaded up in the MultiComp root folder in GitHub. I'll try to keep it up to date. No promises. I've decided to bite the bullet and go ahead and fix the names of all of the entities to match the file name. And if you've done a pull, part of the tree, that might be an issue, but you might have to re-pull the whole tree again from GitHub. I did go through and fix all of the components so the top level entity names all match the file name, and then I went through and recompiled all of the examples up there. So everything compiled and everything at least put something up on the screen that was the prompt, the basic. So it looks like that should work. I've also left the element test bench folder, and that should be checked in as well. And with that, you can drop a single or connect up to a single Vhdl component and test it all by itself, or all the parts below it if there are parts too. I also checked in, or I'm going to check in, a UK 101 all feature set, which includes the best of breed of all of the individual pieces, the Super VGA, the latches, the counters, all of the things that go to make that, plus Crazy Ape's 21K solution. That's going to be in there, or that is in there as well. 7-segment LED, you get a choice there between LEDs and 7 segments, and I chose the 7-segment as the best of breed, because you can always display more information with a 7-segment display than you can with 4 LEDs. So that'll be up in there. It also has the Segmon patched, and this is the 1K UK 101 build. So the downside of it is that I think there's a problem, and I may have done the patch wrong. That might be why it's not scrolling at the bottom. I'm going to have to dig into that and figure it out. Consideration. Anyhow, enjoy. Hope you enjoyed, and hope you found something useful in here. And if you're trying to pick which of these you'd like to do, here's the result and features. I really wanted to do this to know what I had left over. I like that this FPGA has space left over. Thanks for watching. If you want more information, you can see our wiki pages for these products, and we have YouTube videos on them as well. We have a store in Tindy where we sell all of our cards. Thanks for watching our video, and if you enjoyed it, don't forget to like, share, and subscribe.